What are we doing today? We're making elbows and knees that look nice. It won't surprise you to know that the technique for making attractive elbows and knees in Blender is you add some bones, add some constraints and drivers on those bones until it looks right. What probably will surprise you is which bones to add and what drivers and constraints to put on there. So let's do that today. Now what I'm going to do is just show you really quick all the bones, constraints, and drivers, where they are, what they're named, how they work. But if you want to see me tear down a joint, completely delete all the bones, and then re-add them one by one, head on over to filomavero.gumroad.com. So there I have these tutorials. In the tutorials I delete every bone and add them one by one, adding the constraints and drivers, make mistakes, poke around, try and figure it out, all the stuff. You can see my total thought process and everything. If you don't really need tutorials, but you want to support what I'm doing here, please head on over to here as well and just buy a character. You don't have to do anything with them. Just pick a character that gives you about the amount of utility you think I'm giving the world, and help me out. It's the only way I make money, so please go to Gumroad and buy something if you like what I do. All right, so let's take a look. What do we got here? We've got a bone here that's the child of the humerus. It has a stretch 2 constraint to the forearm. The forearm has a bone that's a child of it here, and it has a stretch 2 constraint to the humerus. So this one stretches to this one stretches to this one. Is that the whole thing? No, of course not. There's some extra details there. The first is, let's look at the forearm. It's this forearm correction. It's called inner elbow fixed forearm. And let's take a look at what it does that's special. Two things. One, it has a driver on the head tail, where it will go from a minimum value of 0.78 up to 1. So somewhere in that range, that's what the min 1 and 0.78 means. And what makes it go between those two values? Elbow times 0.09. What is elbow? Elbow is the angle between the humerus and the forearm. So the more the arm is bent, then the more we're going to have this value added to 0.78. So what is 0.78? 0.78 is most of the way down the bone here, and then 1, of course, is all the way down the bone. So here her arm is fully bent. But if we go back to straight, we can see it's at 0.861. That's where her arm is. Well, it's not fully straight, but it's close to straight. Then the other trick about this bone is its Z scale. Z is forward and back here. So as her elbow, and it has a similar driver, right? It's got the elbow variable, that's the angle between the humerus and forearm. And we take 1.12 and we subtract elbow times 0.12. What does that mean? Well, 1.12, in the case of scaling, you're always adding and subtracting from 1 because 1 is your normal scale. So what I essentially want to do is subtract from that a certain amount, but I really want to start from a bit bigger. So that is, if her elbow is straight, it'll actually expand a bit. So let's look at her elbow straight here. So as you can see, 1.013, so what that means is that her forearm is actually bulging out just a slight amount here when that happens. And then when it's fully bent, it gets compressed in to 0.789. It's about 20% smaller. And so it's being pushed, the bicep is essentially pushing into the forearm here. So that gives it a bit of squish there, plus also this points down at the very end when her elbow is bent. The bicep, this is called def inner elbow fixed bicep here. This thing does basically the same thing. It has a stretch 2 constraint, but instead of stretching to the one end of the bone out here, it stretches to the other end of the bone here. So it wants to be, when her elbow is fully bent, 0, but when her elbow is straight, it wants to be 0.117 or so. And so let's take a look at how it does that. That is this driver here on the head tail. So the driver, again, it's the elbow, the angle between the humerus and the forearm is called elbow. And we take 0.18 and we subtract this thing at max of 0. So that just means it's going to go from 0 to 0.18, somewhere in that range. And what's going to make it slide between that range is the elbow angle times 0.07. And so this makes it go from, pointing it to the very tip here when her elbow is bent to pointing a fair bit down her arm here when her elbow is straight. Is that everything? No, if only it was everything, but it's close to everything. The other thing is there's a scale driver on this as well. 2, one for the X is right and left, as it should be in most cases on characters, and Z is forward and back, this direction. So let's start with X. As you can see, it's 1.6 right now, so the X is quite a bit larger. And so what this does is it causes this area to bulge out like this. Let's take a look at that driver. again, elbow, it's the angle between the humerus and the forearm. And what we do is we take 0.5 and add elbow times 0.4. So this is like quite a bit more influence than you saw on the driver for the Stretch 2. And the reason for that is because we're dealing with scale here instead of going from a very small range at the end of an arm. So 0.05 means it'll, at the minimum, it should be about a half, and it'll add elbow times 0.04. Well, if her elbow is straight, which it is here, you can see that X has been gone all the way down to 0.858 here. So that means her bicep is actually narrowed here when her arm is straight. And this actually kind of follows what happens. That bicep is being stretched out here, so it should actually be narrower, and that's fine. Normally you would solve that with a Stretch 2 constraint, and I do have some, I don't have any volume variation, sorry. I don't have any volume variation here because I do it all with the driver. So this gets narrowed here when her elbow is straight, and it gets widened quite a bit when the elbow is bent. The other thing this does is similar to the forearm, that Z, when the elbow is bent, it gets compressed down to 0.714. Let's take a look at that driver. It's just, again, the angle between the humerus and forearm. That's called elbow. We take 1.1 and subtract from it this. And so, again, with scales, you're always adding and subtracting from about 1. In this case, I added 0.1 so that it can scale up some and then scale down quite a lot if her elbow is fully bent. So that gives you everything you need for the elbow as far as the correctives. So how does the elbow actually work other than that? Well, this might be a construct you're not familiar with. A lot of rigs will just have the humerus directly connected to the forearm. But you can see here I have this deaf elbow that's halfway in between. Deaf elbow is, what this does is, it's a concept I stole from Royal Skies LLC that he probably stole it from someone else. But the idea is the elbow doesn't just connect at an infinitely small point here. The forearm and the humerus don't just connect. They actually kind of go around each other. And so by adding this bone, you add some radius to that intersection here about the size of this elbow. And so that actually gives all the deform that you would need if you're a weight painting guru. You can just paint it up, but because I hate weight painting and I use automatic weights, I've added one bone here, this deaf elbow bone R. This is a child of the forearm, so it's a child of this, so it moves exactly with that, but it goes up further into the elbow. And so what this does is just make it so when her elbow is bent like this, you get that kind of bone that points here, and that gives it that look right there. So if you're a weight painting guru, all you do is you just take that forearm and add some of that influence up into the elbow and take it away from this thing, or you can just set it up like I've set it up here so that the weight of the forearm comes up in there as well. So that's how you do the elbow. I'm going to go ahead and pause this, and I'll make another intro for the knee because the knee is a bit more complex, so it'll take a bit more time.